Greetings and salutations, friends. Today we are highlighting an incredible product to suit your load measuring needs. A team of 3 highly sophisticated mechanical engineers took it upon themselves to calibrate the load cell both statically, determine its dynamic characteristics, and basically determine the limitations of this load cell for all of the user's needs. Under the hood of the full bridge load cell is a set of 4 strain gauges in a Wheatstone bridge circuit. As the load is applied, this load corresponds to a change in resistance within the strain gauges, and that change in resistance changes the potential across the green and white wires. Thus, you can read that potential difference and map it to a load. In a highly sophisticated lab, we had our voltage supply powering a range of voltages for the circuit. Of course, our load cell, it was anchored using a C-clip, and it was wired using a resistor, potentiometer, and an amplifier to amplify the signal so we could read it, and a multimeter to calibrate the circuit, and it was interfaced with the MIDAC so we could actually use the recorded data. To determine the static sensitivity of the load cell, we had our load cell anchored to the table as a cantilever, and we had this hook, and we sequentially added weights and collected the voltage readings at each of these values. We plotted these, and thus, from the slope of that graph, we're able to determine the static sensitivity, giving you, our customer, the best data possible. Certainty of 0.0233 pound force and a static sensitivity of 0.0235 volts per pound force. For the dynamic characterization of the load cell, it was once again cantilevered, but this time, rather than sequentially adding weights, one of the team members tapped the edge with a pencil. This response was then recorded with the MIDAC and converted to useful data in the computer and was analyzed. The resulting natural frequency was 1084 Hz with a bandwidth of 237 Hz. The error propagated through the sensor as you take measurements. The design stage is pretty small at 0.01304 pound force, and the experimental total uncertainty was 0.0193. Overall, the total uncertainty was 0.0223 pound force. Upon analysis of the results summary, the natural question is, should you buy this? That depends on your application. This load cell has a small uncertainty, it's repeatable, it's cheap, and it has a moderate bandwidth. Overall, it's good for static measurements, capable of dynamics, but is not preferred. And if you have high frequencies, you might want to select a different instrument. Thank you.